Currently, a local newspaper company sells print subscriptions for $9.30 a month and has 2,400 subscribers. Based on a survey conducted, they expect to lose 20 subscribers for each 10-cent increase from the current monthly subscription price. All right, that's interesting. What should the newspaper company charge for a monthly subscription in order to maximize the income, from the print newspaper subscriptions? So let's think a little bit about their income. And it's actually their revenue, how much money they're bringing in, but I get what they're talking about. So their income, let's just say I for income, is going to be equal to the number of subscribers they have, so S for subscribers, times the price per subscriber, times the price per subscriber. So that's going to be their income. Now in this in the problem, they tell us that the subscribers themselves are going to be a function of price, and that makes sense. If your price goes up, you're going to have fewer subscribers. So they tell us right over here, based on a survey conducted, they expect to lose 20 subscribers for each 10-cent increase from the current monthly subscription price. And the current monthly subscription price is $9.30. So let's see if we can write our number of subscribers as a function of price. So at the current price, we have 2,400 subscribers. But we're going to lose 20 subscribers. So I'm going to subtract 20 subscribers for every dime above $9.30. So let's multiply that. So if we just take P minus $9.30, this would give us the absolute price increase, how much we've gone above $9.30. And if we want to figure out how many dimes we are above $9.30, we could just divide that by 10 cents. So this part right over here, this tells us how many dimes above our current price is P. And then for every one of those dimes, we're going to lose 20 subscribers. So this is probably the most interesting part of this problem. This is kind of the crux of it. How do you set up subscribers as a function of price? Because once you do this, you can then substitute back in here, and then you're going to have income purely as a function of price. Let me show you what I'm talking about. So before I actually even do that, let me simplify this a little bit. So subscribers is going to be equal to 2,400. And then let's see, 20 divided by 0.1 is going to be 200 minus 200 times P minus $9.30. And then we can distribute this 200. So subscribers is going to be equal to 2,400 minus 200P, and then negative 200 times negative $9.30. Let's see, that's going to be 2 times $9.30 is $18.60. But it's going to be $1,800, and instead of $18.60, it's going to be $1,860. So plus $1,860. That's negative 200 times negative 9.3. And now we can add this to that, and we're going to get the subscribers are going to be equal to 2,400 plus 1,860. If you add 1,000, you get to 3,400, and then you add 860, you get to 4,260. So you get 4,260 minus 200p. So we now have a simplified subscribers as a function of price, and now we can substitute this expression in for S in our original equation. So if we do that, we get income is equal to, instead of writing S, we could write 4,260 minus 200p, and then times p. Now we can distribute this p, and we're going to get income as a function of price is 4,260 p minus 200p squared. So income as a function of price, it is a quadratic. And I actually like to write my highest degree terms first. So income is equal to, I'm just going to swap these, negative 200p squared plus 4,260p. So this is a quadratic. And it is a downward opening quadratic. We know that because the coefficient on the second degree term is negative. So this graph, I as a function of p, so if this is the y-axis, that's the I-axis. If this is the P-axis right over here, we know that it's going to be, so this is going to be the P-axis. We know it's going to be a downward opening parabola, and that's good because we want to find a maximum point. A downward opening parabola will actually have a maximum point. If it was upward opening, you'd be able to find a minimum point, but then there's no, it wouldn't be bounded onto the upside. So we need to figure out what price gets us to this maximum point. And this price, this is going to be the vertex. This is going to be the P coordinate of the vertex of this parabola. And let's just remind ourselves how we can find the vertex of a parabola. And there's multiple ways to do it. You could find the roots. You could find the x values that make this function equal 0, and then the vertex is going to be halfway between those points. That's one way to do it. Another way to do it is you could say, look, if I have something of the form I is equal to AP squared plus BP plus C. Instead of writing y and x, I wrote I and p. Well, the vertex is going to be the coefficient, the negative of this coefficient, negative b, over 2 times a. That's going to be the p coordinate of the vertex. P equals that is going to be when you hit the minimum or maximum point. In this case, it's going to be the maximum point. So what's negative b? B is this right over here. So negative b is 4260. It's going to be over 2a, over 2 times negative 200. So that's going to be negative 400. And so what is that going to be? A negative divided by negative is a positive. This is going to be the same thing as 426 divided by 40. And let's see, can I simplify this? Well, let me just see. This is going to be 40 goes into 426 10 times with 26 left over. So it's going to be 10 and 26 40ths, or we could write this as, this is going to be equal to 10 and 13 20ths. And so if we wanted to write that in terms of dollars, because we're talking about a price, we'd want to write this in terms of hundredths. So this would be the same thing as 10 and, let's see, if you multiply the denominator by 5, you multiply the numerator by 5, 10 and 65 hundredths, which is the same thing as $10.65. And luckily, we see that choice. We see that choice right over there. Another way we could have done it is we could figure out, well, what are the p-values that get us to 0 income? And then the one that's halfway in between those two is going to be where we hit our maximum. Halfway between your two roots are when you hit the maximum point. So that's another way that you could actually tackle that. And you could do that just by looking at this original one. You could say, well, when does this thing equal 0? So you could say, when does 4260p minus 200p squared equal 0? And since you have no constant term, actually you could just factor out a p. So you could say p times 4260 minus p is equal to 0. So this is going to be equal to 0 either when p equals 0. And that makes sense. You're going to have zero income if you don't charge anything. Or if 4260 minus p is equal to, oh, let me be careful here. I don't want to, 4260 minus 200p is equal to 0. So that's going to be equal to 0 either when p is equal to 0 or when 4260 minus 200p is equal to 0. This is when you don't charge anything. You're obviously going to have no income. And this is when you charge so much, you're going to lose all your subscribers and you'll have no income. But let's see. If you want to solve for, if you add 200p to both sides, you get 200p is equal to 4260. Divide both sides by 200, you get p is equal to 4260 over 200. That's this price over here. That's the price at which you lose all your subscribers. So your maximum point is going to be halfway in between these two, halfway between 0 and this, halfway between 0 and that. Well, halfway between 0 and that is just going to be half of this. So your maximum point is going to be at 4260 over 400, which is exactly what we figured out before. That's $10.65.